Hi students, this is Mr. Bob. The topic for this video is kinematics and DGUESS. And before watching this video, you should have set up focus notes either by pencil and paper or by using that digital template indicated there. Have a colored pencil or highlighter ready, that is always helpful. The essential question for this video is, what are the kinematics equations and how can I approach complex problems in a way that helps me solve them? So a couple of recommendations for taking notes during this video. Remember, avoid mindlessly copying. If you find yourself doing that, please get up, move around, and resettle. Actively listen and selectively write down some things I say and things that are emphasized by me, but don't try and copy down everything on every slide. If I offer you sample problems, try and make your brain think and work them for themselves, usually pausing the video before continuing on. And then if you're still confused by the end of this video, make sure you identify it in your notes as a point of confusion, so that you remember to follow up with either a classmate or myself at a later point. 3 learning targets for this video. I can describe what is kinematics, I can state the conditions of when the kinematics equations can be used, and I can apply the DGUESS method and kinematics equations to analyze complex situations. Before we get into the nitty-gritty of this topic, I just want to make sure you have a sense of the big picture. Kinematics, the definition is basically, it's the study of how objects move. And the thing I want to emphasize to you is that if we know a little bit of information about an object's motion, then there's a lot of things we can predict about the future motion of that object. And this is really important. And I want to just linger on this point for a second, because we have used these concepts, these kinematics equations and things related to forces, which we're going to talk about soon, to do many things, many incredible things as a species, including we have airplanes that can fly around all this Earth and they can do it so safely. We've sent astronauts into space and they had them come back safely. We've been able to land multiple spacecraft onto Mars safely. And we've been able to predict the motion of planets and stars with astounding accuracy, all because we're applying these kinematics concepts. So the first part of this kind of building the foundation here involves knowing what these symbols mean and what they stand for. And so there's no way around. There is a certain amount of memorization that has to come with this topic, like any other topic, and this is part of it. So you need to definitely know, if you look at an abbreviation, if you see that letter X in an equation, you need to know that that stands for position. And if you see a triangle with an X, that triangle stands for change in, it's a common math term, change in position, which we already know from previous discussions that that's displacement. If you see a letter V with a lowercase I next to it, that lowercase I, or excuse me, that subscript I stands for initial, and V stands for velocity. So this would be initial velocity. Similarly, if you see a V but with a subscript F, that stands for final velocity. A T stands for change in time, that's sometimes written as delta T, and an A stands for acceleration. And I just have one other note to make. You may see videos of other teachers teaching IB physics or talking about IB physics, and you may see IB websites. And if you do, you're going to see a slight difference in what they use for 2 of the variables. So instead of delta X, some IB websites and videos use the letter S for displacement. And some of them use, instead of V sub I for initial velocity, they'll use the letter U. And if they do that, then oftentimes final velocity doesn't have an F underneath it. It just is listed as V. So that's just a difference to be aware of. This next slide is really important, but I don't want you to think you have to memorize the equations you're about to see. In fact, you don't, because I will always give them to you and you'll be able to refer to them. But you do have to know what the letters mean. An important note I want to make, and I'll make it a couple times in this video, is these are known as the equations of motion for constant acceleration, otherwise known as uniform acceleration, meaning that in order to use these equations, the part of the problem or the problem that you're trying to use them on, the object has to be going, basically undergoing constant acceleration. The acceleration cannot be changing, it has to be a constant number. Okay, and again, you don't need to memorize these equations, so let's get into it. This first equation, now I bet some of you are just going to say, oh, VF equals VI plus AT. I actually don't want you to think of these equations or say these equations this way. I want you to list them as final velocity equals initial velocity plus the acceleration times the time. Similarly, the next equation is the fact that the displacement or change in position of an object is equal to the initial velocity times the time plus 1/2 times the acceleration times the time squared. The third equation, the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the displacement. And finally, the fourth equation is that the displacement of an object is equal to the initial velocity of the object plus the final velocity, that quantity divided by 2, multiplied by the change in time. An important note, again, is that these kinematics equations can only be used if the acceleration is constant over the motion that they're predicting. Now, here's an important thing to realize. So if you encounter a problem where an object is moving or a person is moving at a certain acceleration for a certain part of the problem, and then their motion changes somehow, and they have a different acceleration for the next part of the problem, that's okay. What you'll have to do is you'll have to split that problem up into different parts. You'll have to apply the equations to one part where there's only constant acceleration, and then separately apply the equations to the other part where there's a new constant acceleration. Okay, this is a very powerful problem-solving approach that I have basically learned over the years and fine-tuned with other physics teachers. This is called the DGUESS method. I want to talk through what each of these mean, and I want to talk about how they apply to kinematics problems. First, to know what DGUESS means, you can see there on the left, it's an acronym that stands for drawing, givens, unknowns, equations, solve, substitute. Let's talk more detail what they mean. When I say drawing, whenever you approach a physics problem, you want to read through it and then you want to make a well-labeled sketch of the situation. It doesn't have to be too detailed. You don't have to be a beautiful artist. In fact, I usually use stick figures and I usually make my drawings so simple that I do them in 30 seconds or less. In a kinematics problem, it's really key that as part of your drawing, you set up a coordinate system. You want to define one direction as positive and the opposite direction as negative. And you'll see how we do that in examples. The next step is the givens. You want to list your givens. You want to mind the problem, read it carefully several times to make sure you get all the information you can out of it. In a kinematics problems, you're going to use a table, and I call that the displacement vivat table. Okay, displacement vivat, this is kind of an acronym, right? And you'll see how we use that here in sample problems that we're going to do. The third step is the unknowns. You want to indicate your unknowns. And in the kinematics problem, it's easy. If you already have your table, then you just put a question mark in the appropriate spot of the table. The next thing is writing down the equation without substituting numbers. So figuring out which equation is the one that you want to use, okay? And so in this case, with the kinematics problem, what you're going to do is you're going to, with that table, you're going to see, as long as you have 3 quantities of that table filled in, then you can find what the remaining 2 quantities are. And it's just a matter of figuring out which equation you have all the values for except one. So you're going to want to look over your kinematics equations and pick the one where you know all the values except one, and that one that you don't know is what you're trying to solve for. It's your unknown. The next step is to solve. You want to solve for the unknown, and this is going to be true, and this is going to be something that might be hard for you at first, but you want to solve for what you're trying to find, and you want to keep the letters. You don't want to put numbers in yet until you have manipulated the equation with the letters that you solve for the variable you're looking for. So you keep it in letter format until the last step. And then the last step is to substitute. You plug in the numbers and you calculate. And a quick important thing to remember in kinematics problems is that remember your units with your answer. This is something that students frequently forget to write down, or they write down incorrect units. So that's it. I hope you've learned what is kinematics. I hope you can describe the conditions of when the kinematics equations can be used. And you can learn a little bit, or you've learned a little bit about the DGUESS method. The next videos I offer you are going to be where we apply the DGUESS method and the kinematics equations to analyze complex situations. Thanks so much.